Welcome to my class Introduction. Class Standard 11-12, Subject and Mathematics, first paper, chapter name Differentiation, Exercise 9K, Lecture 11. Today's lesson to explain maxima and minima. Differentials of independent and dependent variables. Under the function y equal to f of x, here x is independent variable and y is dependent variable. So the differential of the independent variable x is dx. This equal to infinitely small increment del x of x, and the differential of the dependent variable y equal to, that's when y is dy, and this equal to f prime x dx. Okay. Local linear approximation. Linear means simple. That's mean equation of straight line, equation of tangent, etc. Approximation, that's mean the value nearer to any point, to a function nearer to a point, or approximate value. If y is equal to f of x is differentiable at x0, f of x0, then the graph of the function y equal to f of x can be locally substituted close to any fixed point approximately by the graph of the tangent drawn at the point x0, f of x0. Slope of the tangent line to the curve y equal to f of x at the point x0, f of x0 is f prime x0, and slope is known, then the equation of tangent here will be equation of tangent y minus f of x0. This equal to f prime x0, x minus x0. That's meant from chapter 3, the straight line. We know a equation of straight line if tan slope, that's mean slope is known and a point is given. Here is point x0 and f of x0. F of x0 mean y naught, and equation would be y minus y naught or y1. This is equal to m into x minus x1. As here is point x0 and f of x0, so equation will be y minus f of x0 equal to f prime x0. That's mean this is a slope, that's mean m into x minus x0. By calculating y is equal to this, and y and f of x same, so this equal to, we can write y is equal to f of x. Approximation, this is approximation sign, as we have to find the approximation, local linear approximation. This equal to f of x0 plus f prime x0 into x minus x0. Clear? This is called linear approximation. Okay, by this, using this formula, we have to find local linear approximation. Clear? Increasing and decreasing function. A function y equal to f of x is an increasing function of x if y increases as x increases. That's mean when x increases, then y also increases. As for example, y equal to x or f of x equal to x. As y and f of x are same, so y equal to x mean f of x is equal to x. That's mean when we'll put x is equal to 1, y equal to 1. Clear? And when x is equal to 2, that's mean x is increased, then y also equal to 2. This type of function is an increasing function, and the graph of an increasing function rises as x increases. This is a figure of increasing function. Okay, when x increases, then also y increases. From here to here, this is x and this is y. And when x increases, that's mean the length of x this, from here to here, y also this, that's mean y is increased. Clear? Similarly, a function y equal to f of x is a decreasing function of x if x decreases, sorry, y decreases as x increases. As for example, y equal to 1 by x, y equal to 1 by x, that's when when we put x is equal to 1, then y is equal to 1. But when x is equal to 2, that's mean x is increases, then y is equal to 1 by 2, that's mean half, that's mean y is decreased. This type of function is a decreasing function, and the graph of the decreasing function falls, x increases. The figure will be this. Graph will be decreases as x increases. X increases, y decreases, and the function will be, function of the graph will be this. This type of function is a decreasing function. If f be defined on an interval and let x1 and x2 denote numbers in that interval. Okay, f is increasing on the interval if f of x1 less than f of x2. When x1 less than x2, at the f is here will be decreasing on the interval f of x1 greater than f of x2 when x1 greater than x2, and f is not increasing, here will be constant. The first one increasing, second decreasing, and third constant on the interval if f of x1 equal to f of x2 for all x1 and x2. That's mean first one increasing, second decreasing, and third, that's mean C number constant. Clear? Some necessary formulae. Since slope and derivative are synonyms, we can relate increasing and decreasing with the derivative of a function. Let f be a function that is continuous on a closed interval AB and differentiable on the open interval AB. If f prime x, that's mean derivative of first derivative greater than 0 for every values of x in AB, then f increasing on closed interval. If f prime x less than 0 for every values of x in open interval AB, then f is decreasing on closed interval AB. And f prime x this equal to 0 for every values of x in open interval AB, then f is constant on closed interval AB. And left derivative, that's mean limit h tends to 0 minus mean left derivative f of a plus a is less than f of a, and f of a less than right derivative, that's mean limit h tends to 0 plus f of a plus a is, then x is increasing at the point x equal to a. Similarly, left derivative of f of x plus a is greater than f of a, and f of a greater than limit h tends to 0 plus f of a plus h, then f of x is decreasing at the point x is equal to a. Problem 1. Show that f of x is equal to 1 minus 13x plus 6x square minus x cube is an decreasing function. This is a given condition. We have to find the first derivative of this function, that's mean f prime x this equal to, here will be derivative of 1 with respect to x this equal to 0. Here will be minus 13x as derivative of x with respect to x this equal to 1, and here will be 6 into 2 mean 12 to x, and here will be 3x square. We know this. Okay. Now here 3 into x square minus 4x plus 4 minus 1 follow here is 3 common, so x square here minus 4x, and this into this will get minus 12, but as here is minus 13, so we have to subtract here minus 1. This equal to, you can write minus 3 into x minus 2 whole square less minus 1 less than 0, which is always negative for all real values of x. After putting any value of any real number, the value always negative. As first derivative is negative, so the function is decreasing function. Clear? And show that f of x is equal to x³ minus 3x² plus 3x is an increasing function at x is equal to 2. This is a given condition. We have to find the first derivative. Here will be 3x², here will be 6x, and here will be plus 3. Now putting x is equal to 2 will get 3, which is greater than 0. As first derivative at x is equal to 2 greater than 0, so the function will be increasing function. Clear? Extreme values of a function. A continuous function on a closed interval must attain its minimum and maximum values at least once. Minimum is a singular form of minima. Minima is a plural form of minimum, and maximum is a singular form of maxima. Okay? If the function is differentiable, the minima, this is a plural form of minimum, and maxima, this is a plural form of maximum, can only occur at critical points or end points. Critical points or end points, that's mean a point using this point will get maximum or minimum values. This is a critical points. Points where f prime x equal to 0 are called critical points. Okay, points where f prime x is equal to 0, this is a critical point. Okay, or stationary points. Maximum and minimum values of a function. A function is said to be maximum for a values again, a function is said to be maximum for a value x is equal to c if f of c is greater than every other value of f of x in the immediate neighborhood of x is equal to c. That is, f of c greater than x for all x belongs to c minus h, c plus h. Okay. As for example, the graph of sine x, when x is equal to 60 degree, will get sine 60 degree. This equal to root 3 divided by 2, which is less than 1. But when we'll put x is equal to 90 degree, that means sine 90 degree, this equal to 1. At first we have to put x is equal to 60 degree. That means which is less than 90 degree. Okay. And again, when we'll put x is equal to 180 degree, the value of sine a 180 degree is equal to 0. That's mean at x is equal to 90 degree, we'll get maximum value. Again, at x is equal to 90 degree, we'll get maximum value. That's mean 1. If you put greater than 90 degree or less than 90 degree, but f of 90 degree, that's mean at 90 degree the value of sine x, this is equal to maximum, that is 1. Okay, and other alls for any values of real numbers of the graph of sine x will be less than 1. When you put the value greater than 90 degree or less than 90 degree. Clear? So f of c greater than f of x. When you put here x is equal to c minus a is or c plus a is, will get f of c is greater. Clear? When s is a small positive number. Similarly for minimum, we have to take here x is equal to d and f of d less than f of x for all x belongs to d minus a is plus d plus a is. Clear? That's mean when we put the value less than d or greater than d, f of d always negative. By applying sin x, we can also explain. That's mean the values of sin x, that's mean minimum values of sin x is -1. So when we'll put sin of minus 90 degree, we'll get -1, and other than minus 90 degree, the value will be greater than -1. Clear? So the value, that's mean here when we'll put greater or smaller value of d, f of d always less than f of x. That's mean when we'll put x is equal to d minus h or d plus h, the value of this function will be minimum. Follow the figure. Here at this measurement, this is a f of c, but from here to here, this is a x is equal to c. So this is maximum. When we put x is equal to c minus h, we'll get this part, and when we'll put x is equal to c plus h, we'll get this part. So either c minus h or c plus h, f of c is always greater. But when we'll take here, if this measurement or this measurement will take, that's mean this measurement or this measurement, either take f of d, that's mean from here to here or from here to this point, x is equal to d, and when we'll put greater than d or smaller than d, if this measurement, or you can take this, but here will be x d minus h, this value will be greater than this part, and you can take here another measurement, that's mean d plus h, that's mean f of this measurement will be f of d plus h, both are greater than, that's mean this value and this value greater than this value, that's mean this is a f of d. Okay, like as this part. Okay, when we'll apply this point, any value other than this point, all will be greater than. Clear? So this is the minimum value of this function. Necessary condition for existence of maxima and minima. Since the tangent to the function f of x at a critical point x is equal to c is parallel to the x-axis, therefore f prime c, this equal to tan 0 degree, this equal to 0. Therefore, if a function f of x is maximum or minimum at x is equal to c, then f prime c equal to 0 if f prime c exists. Note that f double prime c mean second derivative, this is the acceleration less than 0. Acceleration less than 0, that's mean direction will be upper side, direction will be upper side, okay, and upper side, this is a negative acceleration due to gravity. Upper side, this is a negative, so when second derivative less than 0, we'll get maximum value of this point, and greater than 0, that's mean lower side acceleration due to gravity, lower side, this is a positive, that's mean f prime c greater than 0 mean positive, then we'll get minimum value at x is equal to c. That's mean second derivative negative mean we'll get maximum value, second derivative greater than 0 mean minimum value, okay. Problem 3. For what value of x the function this maximum or minimum? That's we have to find the value of x. This is a given condition. At first we have to find the first derivative of this function. We'll get this. We know this here. Use u divided by v. The formula u divided by v. And u divided by v, this equal to, we know at first v fixed, that's mean x minus 10 fixed, then derivative of numerator, that's mean this, and derivative of this mean 2x minus 7, and then numerator fixed and derivative of denominator this equal to 1 by v square mean x minus 10 whole square. For critical points f prime x, this equal to 0, therefore x minus 10 into 2x minus 7 minus x square minus 7x plus 6 into 1 by x minus 10 whole square, this equal to 0, implies 2x square minus 27x. By calculating, we will get this. From here we will get this after calculate, that's mean by applying middle factors. Here will be x minus 4 into x minus 16, therefore x is equal to 4 16, that's mean for x is equal to 4 or 16, the given function will be maximum or minimum. Problem 4. Find the critical points of the function f of x is equal to x minus x square minus x cube, maximum or minimum. Find the critical points. Okay, that's mean to find the value of x and y. Okay, where the function will be maximum or minimum. This is a given condition. First derivative will be this. For critical points, first derivative will be 0. That's mean 1 minus 2x minus 3x square, this equal to 0. This implies this. After calculate, we'll get this, and finally we'll get x is equal to minus 1 comma 1 by 3. As x is equal to minus 1 and 1 by 3, therefore f of x will be also minus 1 for x is equal to 1, and f of x, that's mean x is equal to 1 by 3, will get 5 by 27. So x is equal to minus 1, y is equal to minus 1, x is equal to 1 by 3, y is equal to 5 by 27. That's mean the critical points minus 1 1, 1 by 3 comma 5 by 27. This is the required answer. Problem 5. Find the maximum and minimum values of f of x is equal to 2x cube minus 21x square plus 36x minus 20. Given that f of x is equal to 2x cube minus 21x square plus 36x minus 20. Therefore f prime x is equal to 36x square. Here will be 42x plus 36, and f double prime x is equal to 12x minus 42. For maxima or minima or for critical points, f prime x is equal to 0. That means 6x square minus 42x plus 36 is equal to 0. By calculating this, we'll get this and this. That means x is equal to 1 6. Now putting x is equal to 1 in the second derivative of this function, this equal to minus 30, which is less than 0. As a result, the function will be maximum at x is equal to 1 and its value will be f of 1, 21 cube minus 21 1 square plus 36 into 1 minus 20. By calculating this, we will get x is equal to minus 3. This is the required answer. And another point, that is x is equal to 6, we will get plus 30, which is greater than 0. Therefore, f of x is minimum when x is equal to 6 and its value f of 6 is equal to this. And by calculating this, we will get minus 128. This is another answer, that's mean minimum values. Problem 6, show that the function f of x this equal to x cube minus 6 x square plus 24 x plus 4 has maximum nor a minimum value. This is a given condition. First derivative will be this. Now take common 3, will get this, and this equal to, we can write x square minus 2 into x into 2 plus 4. This equal to, we can write x minus 2 whole square plus 4. Okay, for any real values of x, f prime x never be 0. As f prime x never be 0, so the function has no maximum or minimum value. Clear? This is a proof of problem 6. I tried to explain different kinds of math in this exercise, so everybody will solve the remaining math and submit the copy in the group to 11/2020, time 7 p.m. Today after this, thank you to all everyone. Goodbye.